Okay, Chapter 7, Lesson 4, Properties of Similar Polygons. This lesson is really kind of an extension, a little bit of a repeat of Lesson 3. We talked about congruence and similar figures in the last one. This one specifically focuses on similar polygons. So it tells you that they are similar. Then their corresponding angles are congruent. The corresponding sides are proportional. So not necessarily that the sides are congruent, because you can obviously see that this one is bigger than this one, but they do have a relationship in the fact that they are proportional, which we talked about that in the last lesson too. This, we compared small is to big as small is to big, the lengths of the sides. We did that. We're going to continue doing that today. So let's go down and look at example 1. Determine whether rectangle HJKL is similar to rectangle MNPQ and explain. So we had talked about comparing small to big last time. I would still stay with that theory. Do corresponding sides. Small is to big. It's supposed to be a 3. 3 is to 6. 3 is to 6 as 7 is to 10. Well, this would reduce to 1/2. This does not reduce to 1/2. You can check cross products. That is 30. That is 42. That just shows you again, those are not similar. So they are not similar. Even though they have corresponding congruent angles. Well, of course they do. They're all rectangles, so they have 490-degree angles. So there's little wiggle room there, but those are not similar figures because the sides are not proportional. Okay. Moving on down here. I want you to try it, this time with some triangles. Pause it and try this one, please. Okay, back with me. It says determine whether triangle ABC is similar to triangle XYZ and explain. Oh, we know how you love to explain. So let's compare sides. Small is to big, big is to small, however you want to do it. Just keep it straight. 8 is to 12. 8 is to 12 as what? You could pick any of them. 6 is to 8. 6 is to 8. Let's just try cross products here. 8 is to 12 as 6 is to 8. That's 64. 6 times 12, 72. Those are not. Well, what if we didn't try that side? What if we tried 2 other sides? Well, let's try it. Let's try big to little this time. Let's try 8 is to 6. 8 is to 6. I did this side is to this side. 8 is to 6 as 12 is to 8. We still get 64 and 72. Those will not reduce to the same thing. Okay, that would be 1 and 2/6, so 1 and 2/3 if I reduced. This would be 1 and 4/8, which is 1 1/2. So obviously those two are not the same. Now, the only problem that you may run into is if you try, what if you did this? 6 is to 8 as 6 is to 8. Oh, look at that. 48, 48, 6/8 reduces 2 3/4, 6/8 reduces 2 3/4. But remember that they all have to be that way. So just because you find one that is, if the rest of them are not, it's not going to work. All right? Of course, these two will be, because this is a what kind of triangle? If it has 2 sides the same and 1 side's not, that is an isosceles triangle. All right, so if you pick the 2 sides that are the same, obviously they're going to be the same. Okay? So, those are not congruent. The corresponding angles are not even congruent. Corresponding angles are not even congruent. So, check the sides, check the angles, check all the sides. Okay? Let's move on. Now, you're going to put your knowledge to use to find missing measures. So, scale factor, so we've talked about that before, the ratio of the lengths of 2 corresponding sides of 2 similar polygons. So we can use that to find missing sides. Now, this one right here, notice that the M maybe. The m is the one that's missing. So that means you obviously have to use what? Which one corresponds to m? It would be 12. So I would pick out the missing side and its corresponding one right away. So I would say m is to 12. Now look, we're going big to little this time. So m is to 12 as 24 is to what? Do we know this one? No, so we can't even use 24. But we can say m is to 12 as what? These two we have that correspond. So if we do big is to little, then we have to do big is to little. 15 is to 10. Now, if you're talking about this and you're looking at it, some of them work out to where they could be like reducing fractions. This one does not look to be that way. So I would use cross products. How would you write 10 times m? Well, 10 times m, a letter times a number, is just 10m. 15 times 12. 15 times 12. $180. $180. All right, now you've got a basic algebra problem. Divide both sides by 10. M is equal to 18. And if we scroll down, we will see that actually that is the answer. So M is 18. So you can do and find the scale. They teach you two different ways. They talk to you about method one being the scale factor method. So find two corresponding figures and get the scale factor and then take that times 12. So if you look back up here, you've got scale factor of like 15 over 10. That would reduce to 3 over 2. And then you know that since these are similar, they're going to have the same proportional relationship. So you could do 15, get my pen back here. I could do 15 over 10, which reduces to 3 over 2. And then I know that this is going to be 3 over 2 times this, if you wish to do it that way. All right, which would be 36. I'm having trouble making threes today. 36 over 2, which is in fact still 18. So the answer stays the same. I think proportional methods are the way to go. That's just my opinion, though. So you can choose either one of those methods that you wish, but you will see me using proportions more often. And in fact, the more you can get used to using proportions, proportions can solve a lot of problems in math. Surely it can. All right, so I want you to try got it, B and C, and then this very short lesson is done. So pause and try each of those missing measures, please. Okay, back with me. B, you are looking for WZ. You are looking for WZ, so you are looking for this one right here. If you're looking for WZ, let's just call this one my star side. If I'm looking for that star, which one corresponds to that star? Which one corresponds to the star? It would be 13. Now, I need two other sides that correspond. So I went bigger shape to smaller shape. So I've got these two right here. Let's look for bigger shape to smaller shape. All right, since I'm going to be using that, let's change that star. Let's just make that a big A. All right, so I've got, using cross products, I've got 10A. You can call it 10 star if you wish. And then I've got 15 times 13. 15 times 13. 195. Now, what would I do with that? Well, then that's just a basic algebra equation. So I divide both sides by 10. It's not going to come out evenly, and that's fine. Not everything in math has to be a nice, round, even number. So I've got 195 divided by 10. Move the decimal point back one time or use your calculator, however you want to do it. 19.5. All right, so that is WZ. Let's look at AB. Let's erase this part off of here. And now AB. So I'm looking for this one. Now let's put my letter right there. So I'm looking for this one. Which one corresponds to this? It would be this. So I'm going to say x is to 24. Again, doesn't matter if you do x is to 24 as 24 is to x, as long as you are doing the same with the one this way, as long as you are consistent. So this is to this as, again, I would go with the two that you know. This is to this. So x is to 24 as 10 is to 15. So here I've got 24 times 10 is 240 equals 15x. Divide both sides by 15. So 240 divided by 15, 16. 16 is my answer. So AB is 16. Okay. Again, get used to using those proportions. They can help you out immensely. Okay? So good luck with those. As always, see me if you need help. Good luck.